Your monitoring program is live, your alerts are coming through, your sensors are online, but why does it feel like your team is drowning? Hi, I'm Kagen Wittbold, Sales and Value Engineer here at Augury. Welcome back to 5-Minute Maintenance, where we break down one concept, one framework in 5 minutes. Let's get into it. Alarm fatigue isn't just about volume, it's about accuracy as well. Most other vendors in this space send detections straight to the customer and ask the customer to make heads or tails of that information to determine if it's accurate or not. The problem with this is if you have 100 machines and you get 500 alerts, only some of those will be accurate, and maybe only one will be an actual maintenance problem. This doesn't scale, and that doesn't really help anyone. The problem isn't just too many alerts, it's too many alerts pointing at the wrong things. Alarm accuracy and alarm fatigue go hand in hand. If we're constantly alarming on the wrong sensor for a piece of equipment, we could possibly be over-maintaining a piece of equipment in one area and under-maintaining in other areas, leaving us with a problem that goes unresolved. So let's kind of take a look at what that looks like, right? Of these 500 alerts that are generated, your team may only be able to action 50. This leaves around 450 unactionable alarms or alarms that become nuisance, fatigue alarms that your team can't actually do anything with. This doesn't scale, and this creates alarm fatigue for your team and creates an erosion of trust within the platform. Teams stop trusting the data when they continue to get false alarms. Let's take an example, Compressor, for instance, of a piece of equipment that is highly variable, that constantly speeds up, slows down, and is variable based on what's happening in the facility. These process fluctuations may look like maintenance problems to the AI, but in reality is just a process fluctuation out in the field. This is important to differentiate because those process fluctuations are spikes in the data rather than trends. The trend is your friend. You are looking for trend changes rather than individual spikes in the data. Let's take a look at an example of what a process alarm could look like versus an example trend alarm. So for example, if we look at vibration over time, and we look at process problems, they'll look like this. They'll have individual process fluctuations and spikes and random behavior that is kind of anomalous, right? These individual spikes are process fluctuations rather than potential maintenance problems. Trends, however, this kind of behavior of vibration over time, this is the kind of behavior that indicates wear, or a trend of anomalous behavior that is significant in a maintenance problem. The trend is the thing we actually want to generate an alarm for. This is the anomalous behavior, not these individual spikes. So how does Augury think about this general workflow? How does Augury screen for these process alarms? Well, we utilize the human in the loop. What does this look like? Well, Augury's AI is looking at trends and spectral information and generating detections. In this case, let's say we generate a detection. From here, this detection goes to a human, a vibration Cat 2, Cat 3, or Cat 4 analyst who's reviewing this information and making heads or tails of the information generated. From the human review point, this is where we determine if this is a real problem or if this is a process anomaly. This is where we're looking at motor speed and other operational data to determine if this is a process alarm. If it is, log it and don't send an alarm. If it is a maintenance problem, send the alarm and generate the evidence to support your claim for why you believe there's a problem. From there, you need to determine if this is a severe alarm, if this is urgent. If it is, act immediately. This is when we escalate to danger. If it is not urgent, we escalate to alarm and we want to plan a repair. We want to make sure we get parts on hand so we can schedule the repair at an appropriate time rather than taking downtime immediately. The point of this process is to generate actionable alarms, such that when you get an alarm from Augury, you know that it will be accurate. Your team will be able to find something when we send them evidence. What does this look like in the real world? Let's take a compressor. We spoke about this earlier. Let's take an example, high pressure compressor. Your plant may have one. A lot of facilities utilize one for compressed air around their facility. In this case, a highly complex piece of equipment, a motor, a gearbox, and a compressor, probably 6 to 8 sensors depending upon the application. The point being is that this type of equipment constantly speeds up, slows down, and is heavily dependent upon process fluctuations out in the facility. We see a lot of detections for them. This is one that's been installed for about a year. We've had 50 plus detections on this machine. You'll notice that this machine health timeline has never come out of acceptable. What this means is that this machine has never actually seen a maintenance problem, and all of these detections have been reviewed by a human and determined to be false. These aren't necessarily false alarms, but they are detections that have not been sent to the customer. This is to make sure that we don't over-fatigue them over process anomalies rather than maintenance problems. This is why the human review is so critical in our process. It makes sure that our alarms are accurate. And this is where our supporting evidence really comes into play, that we know when we send you an alarm, it is going to be 100% accurate. A program is only as good as the team actioning the alarms sent. If there's no action, there's no results. We want to make sure our alerts are prescribed, are actionable, and prioritized in a way that your team can act efficiently. If you're curious about what this looks like, take a look at the link below. Otherwise, I'll see you in the next 5 minutes.